Hello, today we're going to go over the Quiz 2 review for Chapter 1, and I'm just going to cover all the solutions. That way, if you need any help, you can reference these and get some help. Number 1 here, it wants to find whether the equation is a function, yes or not. No. In fact, 1 through 5 are like that. What I want you to do with these is I want you to be aware of when it's not a function. Knowing when it's not a function is the best way to tell whether it's a function or not. So when do we have not a function? It's anytime we can get two different y values for a particular x value. So for instance, if we've got a circle going on, a vertical line, or we're taking the positive and negative root of a number or an expression, that's when we're going to have not a function as far as Chapter 1 goes. So looking at this first question right here, it says x squared plus y squared equals 49. Now you could recognize right off the bat and be like, hey, that's the equation of a circle. If you recognize this, it is the equation of a circle where it's centered at 0, 0 and has a radius equal to 7. So maybe you recognize that right off the bat, maybe you don't. But you could put on your quiz and you say, no, this is a circle, and I'd be happy with that. But let's say you did not recognize that because, you know, we've got a whole lot of other equations to be looking at here. If you didn't see that right off the bat, you can get y by itself and see if it's a function or not. So to do that, you subtract x squared from both sides. And then you take the square root of both sides. So when I take the square root, I introduce this radical here. I have to take into account that there is a positive and a negative root. And now when I see this plus or minus here, it means that if I put in an x value, say, of 0, when x equals 0, what does y equal? Well, y equals positive and negative square root of 49. So y could be positive 7, but y could also be negative 7. So one x value gives me two different possible y values. So therefore, it's not a function. Now you could put a whole bunch of different x values in here, and each time you'd get two different possible y values. And so that's why we're going to say that's not a function. You only need one case to show it. But I think the easiest way for this one is to recognize that it's a circle. All right, on the next one, we've got y minus 4x squared is equal to 36. So my question is, well, let's just get y by itself first. You get 4x squared plus 36 there. Now with this one, it's just a regular old polynomial. So it's going to be, yes, it is a function. Notice it's not a circle. The y is not being squared there. There's no square root being done here. And, sorry, not the square root, but there's no plus or minus square root. And it's not a vertical line. And you can even think about it like, there's no way I'm going to put in one x value and get two different y values here. We're squaring the x, times it by 4, and adding 36. We're not going to get two different answers when we square x, you know, no matter what number you put in there. So this one is going to be, yes, it is a function. All right, next one, number 3 here. Number 3, I'm seeing it is a line. And it's not a vertical line. You know, if you recognize this as ax plus by equals c, that's the standard form of a line. But maybe you didn't recognize it as the standard form of a line. And we want to get y by itself, just to kind of see it in a different manner. So subtract 2x from both sides, you get 5y equals negative 2x plus 10. Divide both sides by 5, I'm going to get y equals negative 2x over 5. I'm writing that all funny there. Let's do this again. Y equals negative 2x over 5 there plus 2, because we got to divide each term by 5 when we divide by 5 there. So this becomes negative 2/5, and then this right here becomes 2. So now we see it in y equals mx plus b format, where negative 2/5 is the slope, 2 is the y-intercept, but none of that matters. We know it's going to be a line. And so we got yes here. It's not a vertical line, so it's a function. All right, number 4, we have a square root right here. We got y equals the square root of x plus 5, and this is going to be a function. Yes, it is. We just need to make sure that there is no plus or minus there. And whoever originally wrote this problem out said, I'm going to make it a positive root, so you don't have to write the plus symbol. It just means to take the positive root. Now, had this question been phrased like this, had it been y squared equals x plus 5, if that was the original question there, is it a function or not, this would be a no, because when you get y by itself, you have to square root both sides, and you get plus or minus here. Why do we have plus or minus here but not here? Because this written in black right here, that's the original equation. So whoever wrote that, the teacher or whoever's writing out this equation, wants you to take the positive root, or they would have put a minus sign here. Now on this one, written in brown, that's the original y squared equals x plus 5. If I give you that, then as the teacher, I'm wanting you to take the square root, and you don't know if I want you to take the positive or negative, so you've got to do both. And when you do both, you end up with a situation like on number 1 that we did, where you get two different answers, two different y values for every x value. So this one would be no. But as far as number 4 in the review goes, it's yes, because it's the positive root. All right, one more here, number 5. Number 5, we're going to add 1 to both sides, and we get x equals 1. Now, x equals 1, what does that look like when we graph it? It's a line, and we got a point on the line everywhere where x could be equal to 1. So if this is 1, 2, 3, it's a vertical line. And obviously, that's not going to pass the vertical line test. You got a lot of different y values for each x value of 1 there. So this is going to be no because it's a vertical line. So when we look at these, what I want you to think about is, do we have a circle here? Are we taking the square root of both sides somewhere along the way, and we've got to take the positive and negative root? Or do we have a vertical line? That's when you're not going to have a function. So be aware of that. And then, of course, we're going to see some cases where we've got a lot that is a function. So you should be thinking about these graphs, what they look like, just to kind of verify in your head, like, yeah, that's a line or that's a parabola. And so you know right off the bat, like, hey, these are functions and which ones are not. So the next one, the next set of problems, starting with number 6, they want us to find the domain of the function. So when we look at this, once again, we've got a set of rules we need to follow. Just like we did when we found whether it's a function or not, we've got some quick, easy rules to try to keep up with here on what the domain is. So what I want you to pay attention to in Chapter 1, and this will change as we learn more about other functions, is in Chapter 1, we want to make sure that if we've got a fraction, that the denominator is never 0. And then if we've got a square root symbol, that we're not taking the square root of a negative number. So that's what we want to be aware of as we do these. Now number 6, I don't have a fraction there. I don't have a square root. And so we're going to just say the domain is all real numbers. Boom. Negative infinity to infinity. Make sure you write your answers in interval notation. Don't give me all real numbers. Write it out, going negative infinity to infinity. Number 7, this time I do have a fraction, so I want to set and make sure the denominator is not equal to 0. So I say, when does it equal 0? Well, the whole thing is equal to 0 right there. So in this case, since it's just the variable, t is the variable here, t can be anything but 0, because when t equals 0, the bottom equals 0. So our domain for this is going to go from negative infinity to 0, skip over 0, and then go to positive infinity. Number 8, there's no fraction involved here, but there is a square root symbol. So we want to make sure that, we're not taking the square root of a negative number. Remember, we can take the square root of 0, but we cannot take the square root of a negative number. So I'm going to take what's underneath the radical here, and I'm going to say, let's make this thing greater than or equal to 0. And so it can equal 0 or it can be bigger than 0. That's a fancy way of saying that it is positive. Add 10 to both sides, and we get x is greater than or equal to 10. And you can test this out. If you put 10 in right here, this blue box becomes 0. And yeah, you can take the square root of 0. But if it's, say, less than 10, if you put 8 in right here, 8 minus 10 is negative 2. Can't take the square root of a negative number. If it's something bigger than 10, then you'll get the square root of a positive number, so that works. So on this, we're going to start at 10, and then we're going to go off to infinity. Notice that I put the bracket around 10 because it's equal to, it's including 10. And then we go up to infinity, put the parentheses around infinity, because we never include infinity. It's not a number. All right, let's look at number 9. Number 9 is a fraction. So if we've got a fraction going on here, we need to take the denominator and make sure that denominator never equals 0. So let's set it equal to 0. X squared minus 2x equals 0. And to solve this, we're going to factor it. So I'm going to factor out what's in common, the x, and I get x times x minus 2 equals 0. And we're going to set each factor equal to 0. So x equals 0 and x minus 2 equals 0. Solving this one on the right, we get x equals 2. These are what x cannot equal, because when it does equal that, it makes this green box 0, and therefore we're dividing by 0, and that is a problem. So these are the two numbers I'm going to throw out of the domain. And when I write this out, I'm going to start at negative infinity, and you go to the smaller of the two numbers first. In this case, it's 0. And then pick back up at 0. We're going to skip over 0, go to 2, and then start at 2 and go off to infinity. So that is our domain for number 9. All right, that takes us through domain and writing out an interval notation. The next thing we're going to look at here are the zeros of a function. So the zeros of a function, remember, are the same thing as our x-intercepts. So the same process occurs as when we find x-intercepts. We know we're crossing the x-axis, which means the y value is 0. So when you solve for these, you're going to let the y value equal to 0, and then you're going to solve for x. In this case, we're going to subtract 2 from both sides, and then divide both sides by 5. We get negative 2/5 is equal to x. That is our 0 there. And you can write this out as when x equals negative 2/5, y is equal to 0. All right, so that is a point, not interval notation anymore here. You got to think of the context of the problem. That is a point on the graph where it crosses the x-axis. Now, number 11 is a fraction. So when we talk about the domain, not the domain, but the zeros of this thing, that's when we're going to set the numerator equal to 0 and solve. What I said a second ago, domain is going to be setting the denominator equal to 0. For the zeros up here, we're going to set the numerator. So I'm going to let x squared minus 9x plus 14 equals 0, 14, and then I'm going to solve that. So I want factors of 14 that add up to the middle term, negative 9, and I'm thinking 2 and 7. If they're both negative, when you multiply them, you get a positive 14, and when you add them, you get a negative 9. So that's what's going to work here for me, and I can take the shortcut, because the leading coefficient is 1. So I've got x minus 2 times x minus 7. That equals 0. So x equals 2 and x equals 7. Those are going to be my zeros. Now, it's important that we check if we're finding the zeros, the numerator here, these x values better be part of the domain. So if you haven't solved the domain already, you can always plug these two numbers into the domain here, or into the denominator, and make sure it doesn't make the denominator equal to 0. 4 times 2 is 8, 4 times 7 is 28, so it doesn't have any domain issues, and so my zeros are when x equals 2, y equals 0, and when x equals 7, y equals 0. And there we go. All right. Number 12. Number 12, once again, we're finding the zeros, so we're going to let y equals 0 and solve this for x. So add 1 to both sides, and then square both sides, and then divide by 2. And I get x, oh, you can't see it there. There we go. What do we say? Add 1 to both sides, square both sides, and then divide by 2. So you get x equals 1/2. When x equals 1/2, y is equal to 0. You can always check these. You can plug them back in. 2 times 1/2 is 1. Square root of 1 is 1. So you get 1 minus 1, which equals 0. All right. And that takes us through number 12. And so just remember that when you are factoring, you're going to want to make sure you set the y value equal to 0 and then solve for your x. And it should get to you there every time. You might have to do a little bit of factoring with it. And so that's why in this chapter we also want to do some factoring practice, because a lot of times in this class we're going to have to be factoring. So here's our trinomial. We're going to factor this one. 1 times 12 is 12, and we want factors of 12 to add up to 7. I've got 3 and 4. 3 times 4 is 12, and they add to 7. Because the leading coefficient here is 1, I can take the shortcut and just put these numbers with an x. So we get x plus 3 times x plus 4. There it is, factored out. Notice I don't set these equal to 0. I'm not solving anything here. I don't have this set equal to anything. And so in this particular case, you got to pay attention to the directions. I'm saying just factor it. If I'm asking for the zeros of the function, then I'm going to set it equal to 0 and say, okay, we got x equals -3 and x equals -4. But don't give me the zeros if I'm asking you to just factor it. Leave it in its factored form there. All right, number 14 is saying x squared minus 81. You've got to recognize that's a difference of squares. A difference of squares happens when I've got a minus sign and it's a binomial. And usually we're doing this when both of these are perfect squares. So you square root the first term, write it down twice. Square root the last term, write it down twice. Put a plus symbol with one, a minus with the other. Wrap them in parentheses. And just always double check and make sure you can't factor it any further. If you can factor that further, you need to. But I don't see any room for it to be factored further. This one right here, number 15, I realize that's copied down incorrectly. I just saw that. This should be x to the 4th minus 25. That's what you've got on your review there. So that's what I'll work through here. So x to the 4th minus 25 is still a difference of squares. We're still going to take the square root of x to the 4th, which is x squared. We're going to write that down twice. And then we're going to take the square root of 25, which is 5, and write that down twice. Put a plus with one, a minus with the other. And that's as far as we can go. If 5 was a perfect square, we could factor that one again, but it's not, so we're going to stop right there. 16 is a little bit different because it's not a trinomial. We've actually got 4 terms here. Now, sometimes when we have 4 terms, we can factor by grouping, and then other times we have to use different methods. In Chapter 1, you don't know those other methods, so if I give you 4 terms, more than likely, you're going to have to factor by grouping. We always want to check when we look at this and make sure there's nothing in common that we can factor out first. There's not. So I'm going to group the first 2 together and group the second 2 together there. I'm going to factor out what is in common right here, which is a 4 with the numbers, and then with the variables is an x squared. Dividing each one of these terms by 4x squared gives me an x, and then minus 6 right there. Over here, when I factor out something, I want what's in the parentheses left over to be x minus 6, so they match up. And so I need to factor out a -1 to make that happen. Now what I've got is one big binomial. This is one term minus this term right here. And I can factor out the x minus 6. So if I factor out x minus 6, what's left over is 4x squared and a minus 1. Now we don't want to stop here. We want to make sure that we're checking that there's nothing else that can be factored. And on this first one, x minus 6, you can't factor that any further. But on this one, 4x squared minus 1, that is a difference of squares. So I'm going to square root the first term, which is 2x, write it down twice, square root the next term, 1, write it down twice, put a plus with one, a minus with the other, wrap them in parentheses, and that's it. So the next set of problems, I believe, let's see where we're at, number 17 and 18, I want you to tell me if the function is increasing, decreasing, or is it constant. And the key to these are I want the x intervals that make y go up, down, or stay the same. So you should be writing this in interval notation, but it should only be x values. So if we look at this first one, I'm going to take you over to the computer, and as we look at this, we want to go left to right and give the x intervals as they occur here. So as I go left to right, starting at -3 to 0, I notice that as -3, or x goes from -3 to -2, my y values are going up. And then as it goes from -2 to -1, they keep going up, and then y keeps going up until it's a maximum value at 3. And then y starts to go down. So from -3 to 0, y is going up. And that's what I need to write out when I am writing these out on my increasing, decreasing. I'm still here. This camera is off though. There it is. Sorry, my camera, it turned off, had to switch out the batteries. So anyway, as I was saying, as x goes from -3 to 0 on this, y is going up. So that means it's increasing as x goes from -3 to 0. Take a look back at that on the computer. As x goes from -3 to 0, y is going up. Now right here, the y values start to go down as x goes from 0 to 3. So as I write that out, I'm going to say it's decreasing from 0 to 3. And then it's never constant. We never have a y value staying the same. So in this case, this is our answer here. Now if we look at the next one, number 18, oh, by the way, before I move on to 18, please do not give me the y values. Don't tell me from 0 to 3 it goes up and then 3 to 0 it goes down. You'll have that wrong. I'm asking for the x values that make y go up and the x values that make y go down. So be careful as you do that. In fact, I would suggest to you as you finish your quiz or tests that you go back and you just take a second to make sure you gave me x values on those problems, because it's a very common mistake. Students get mixed up in the test and they start giving me y values. So be sure to give me x values there. All right, for number 18 here, we can see immediately that x is decreasing from negative infinity all the way up to negative 4. So it's going down there. And that's what I'm going to write out in that space. You'll have a space like this on the quiz where you got to write where it's increasing and decreasing. From negative infinity all the way up to negative 4, x is going down. And then what happens here? From negative 4, right here, all the way up to 0, the y values are going up as x goes up here. And so that's what I'm going to write down. The x values, as they go from negative 4 to 0, y is increasing. And then when we get back to going from 0 to 2, we can see that the y values are going down as x goes from 0 to 2. So I need to put that again as decreasing from 0 to 2. Y values are decreasing as x goes forward there. And then as we go from 2 to 4 on the graph, notice the y values are not going up and they're not going down. They're staying the same. So that's what we mean by constant there. So I'm going to switch back and say, all right, it's constant from 2 to 4. And then lastly, from 4 to infinity, if you look at the graph, from 4 to infinity, our y values are going up. So we're going to say that that is increasing. So from 4 to infinity, we're increasing. So there we are, increasing, decreasing, and constant. That's how we want to take care of those. All right, moving down to these odd, even, or neither functions. Remember that if a graph is symmetrical over the y-axis, and what we mean by that is we can fold it on the y-axis and it matches up, then it's even. So this one, number 19, is even. Number 20, notice 20 does not fold on the y-axis, so it's not even. So our next question is it odd? Odd means we can take it and turn it completely upside down and it would look exactly the same. This is not going to look exactly the same if we turn it upside down. So 20 is neither. It's neither odd nor even. And then next, number 21, it's not even because if we fold it on the y-axis, it doesn't match up. But if we turn it completely upside down, it looks exactly the same as 1 over x. So 21 is an odd function. 22. 22 can be turned completely upside down. It's the same. So the sine of x, number 22, that is an odd function. And then lastly here, 23, if we fold it on the y-axis, it's going to match up. Kind of reminds me of a bird or something like that when I see that cosine function. But it's even because if you can't tell that folding on the y-axis, it matches up, you can always look and say at negative 3, we're at negative 1. At positive 3, we're at negative 1. At 5, we're a little bit, maybe around a third. At negative 5, we're at the same y value. That's what even functions are. It doesn't matter if you put in the positive value or the negative value, you get the same y value. All right? So that takes us through the end of this review. I kind of went through it quickly because it is review, and you can always slow it down if you want. Plus, you got all the videos I've already made explaining these in more detail. So I didn't want to go super detailed in this when you're probably just looking for a refresher on a particular problem. If you're not looking for a refresher, I recommend you go back and watch the videos where I did go through things in detail. That way you can get caught up and prepared for this future quiz. All right. Hope that helped you out a bunch. Let me know if it did, and I will see you in class when we go to take the quiz. And I hope you're having a great day. Thanks for working hard.